everyone. I wanted to solve problem number 19 from your homework packet. This is the circuit with the 4 resistors in it, where R1 equals, see where that R isn't coming up, there we go. R1 equals 10 ohms. R2 equals 15 ohms. R3 is 20 ohms. And R4 is given as 25 ohms. So the first question is to determine the equivalent resistance for the circuit. Whenever you're looking through here, you know that you have two equations. One is for series and one is for parallel resistors. Of course, in series, we would say that R equivalent equals R1 plus R2 plus R3, and so on and so forth. You just keep on going. If it's in parallel, you have the equation 1 over R equivalent equals 1 over R plus another 1 over R, etc., 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 for all the different resistors that are in parallel. The way you can decide if something is in series or parallel is to take a little walk around the circuit. So for example, we could start at the left side of the battery over here. And as we're traversing from the left side, we want to loop all the way around over here and get to the right side of the battery. You'll be able to tell if something is in series if you absolutely have to go through a certain resistor to get through to another place. If it's in parallel, that means you have a choice. So for example, we could keep proceeding left. We have to go through R4. There's no path that we can take that would exclude R4. So R4 must be in series with something. So we've got R4 in series, and we're going to continue on, and now we're given a choice. We could either go straight through the R1, R2 path, or we could go through the R3 path. If we go through the R1 path, we have to also go through R2 to get around to this other side of the circuit. That means R1 and R2 are in series with each other. Or we could just take the R3 path, simply going through over here. Nevertheless, we get a choice, and so the R1, R2, which is in series, must be in parallel with R3. So we can reduce this circuit right away and simply combine R1 and R2 to make one resistor. Well, since they're in series, we know we can use our equation over here, and we can get rid of one of these resistors and just replace it with, let's say, 125 ohm resistor, because we have R1 plus R2, which is 10 ohms plus 15 ohms. If we want to collapse this even further, we have our 25 ohm resistor in parallel with R3, which is 20 ohms. So we use our equation 1 over R equivalent equals 1 over 20 plus 1 over 25. Go on ahead and type that in your calculator. And don't forget, when you do 1 over 20 plus 1 over 25, don't forget to invert that, because what you've calculated is just 1 over R. Once you do that, you should get 11 ohms. So now what our circuit looks like is we would have a 12-volt source right here, connected to R4, which is 25 ohms, and then connected to a resistor of 11.111 continuing on ohms. So we have 11.1 and 25. This is just a simple series circuit. To go around the loop, you have to go through 25 and 11.1. So that means that adding those together, the R equivalent of the entire circuit should be 36.1. That just keeps on continuing. This is 36.11 ohms. So that is the answer for part A. The next part is part B, where they say determine the current in the battery. Well, okay, current is represented by I in our equations, and the wonderful, useful equation we have is Ohm's law, V equals IR. Well, we're looking for I, so if we have V and R, we can definitely find I. Well, the voltage is given to us, that's 12 volts right here, and we have resistance. That will be the equivalent resistance of the circuit which we just found on the previous slide. So we simply put in 12 volts equals current times 36.11 ohms. Dividing 12 by 36.11 to solve for I, we get that current equals 0.332 amps. You can call it 0.332 amps, or you can call it 0.332 coulombs per second. So that's how much the battery is, let's say, pumping out every second is 0.332 coulombs. This is important to think about because the battery is not aware of what it's hooked up to. We see that it's hooked up to 4 other resistors, but it could just as easily be performing the exact same way and be hooked up to one resistor that's 36.11 ohms. This is important because it gives us the current through R4. When you realize that this 12-volt battery pumps out 0.332 coulombs every second, we know that when it gets pumped out, it has to go through R4. Yes, it'll get divided between the R1, R2 path and the R3 path, but everything that it pumps out has to go through R4, just like if you're pumping water around a circuit. So now we know that, let's say R4, which is 25 ohms, we have 25 ohms and 0.332 amps. Hopefully by now, with your familiarity with Ohm's law, you're thinking if I have R and I have I can find voltage. Very helpful thing to do, which will help us on our way to part C. So if we use V equals IR again, and we plug in our resistance that we just got here and our current from over here, we find that the voltage drop across the R4 battery is 8.3 volts. So multiplying those two together, we get 8.3. You have to be sort of a detective in these problems and collect all the information that you can and deduce other ideas from the information that you've been given. So if we know that 8.3 volts is the voltage drop, or sort of like, let's say, energy loss across resistor 4, well, we started off with a potential of 12 volts. By the time we go around the entire circuit, we need to be down to 0 volts of potential. So if we have 8.3 as we go through R4, that means from this point right before the junction, no matter which path you take, by the time you get down here to the other end of the battery, you're going to drop 3.7 volts because 8.3 plus 3.7 equals 12. So now looking at R1, R2, and R3, we know that they're in parallel. Parallel, from your basic definitions, implies that the voltage drop is the same, but the currents will be different. So we were just saying that 3.7 volts will be the voltage drop across this R1, R2 branch or the R3 branch. So now, again, we have resistance and voltage. So voltage equals 3.7 volts. We can combine R1 and R2 together because they function as a 25 ohm resistor. With V and R, we can find I. So V divided by R will give us I, which in this case, through the R1, R2 branch, we would say 3.7 volts is the voltage drop across the whole thing, divided by 25 ohms. This gives 0.148 amps. You might wonder what the significance of finding the current through the equivalent resistor is, the equivalent resistor, of course, being 25 ohms. Well, we know that that 25 ohm resistor is really just made up of one resistor of 10 ohms and another resistor of 15 ohms. Those are both in series. From your basic definitions, you know that in series, they have the exact same current. Thus, if the current through the 25 ohm resistor is 0.148 amps, that means 0.148 amps flows through R1 and flows through R2. If you want to look at something kind of interesting, we could find the current through the R3 resistor. Same tactic, 3.7 volts, instead divided by 20 ohms. Once you've calculated what that equals, take that number and add it to 0.148. What would you get? If your guess was 0.332 amps, you are correct, because that is the amount of current that flows through R4. It gets split up between the R1, R2 branch and the R3 branch, and then combines back to your original starting current. For part D, we are determining the power dissipated by the R2 resistor, which is the 15 ohm resistor. Well, we know that the resistance is 15 ohms, and the other information we have is that the current is 0.148 amps. Using I squared R, we can find the power now in resistor 2, because one of our basic equations was P power equals I squared R. If you plug those numbers in, you should get about 0.33 watts, or a third of a watt. Other equations you could use are V squared over R, or simply I times V. All of these things equal power, and you can just choose whichever equation you would like. For example, in part E, when they ask you to determine the power dissipated by the R4 resistor, that's that first 25 ohm resistor down there. We have all the information about it, voltage, current, and resistance. So we can pretty much use any one of these equations that we would like. So for R4, we said that it was 25 ohms. We knew that there is 0.332 amps flowing through it. Already plenty of information to calculate power. But we also know that there's an 8.3 volt drop across the resistor. So pick out your favorite equation from over here, I squared R, V squared over R, or IV, and calculate power. So lastly, for part E, you should get 2.53 watts. If you can calculate that, then you are quite set for the free response in our test. Good luck.